October 1957. The Soviet Union took the world by surprise with the launch into space of Sputnik, the first artificial satellite. In a matter of months, US President Dwight Eisenhower and Congress initiated measures to build US expertise in space exploration, and that included the creation of NASA, a civilian space exploration agency. Welcome to the Why in History. I am Ajay Kaul, and today we look into the history and evolution of space exploration in modern times. Though astronomy has been a science since ancient times, the first person in modern era to study in detail the use of rockets for spaceflight was a Russian schoolteacher and mathematician, Konstantin Tsiolkovsky. In 1903, his article Exploration of Cosmic Space by Means of Reaction Devices laid out the principles of spaceflight. And up to his death in 1935, Tsiolkovsky continued to publish sophisticated studies on the theoretical aspects of spaceflight. He never conducted any practical experiments in rocketry, but his writings greatly influenced space exploration research in Soviet Union and Europe. In the 1920s, Robert Hutchings Goddard, a professor of physics at Clark University in Massachusetts, began to experiment with liquid-fueled rockets. His first rocket launched in Auburn on March 16, 1926. It rose to 12.5 meters or 41 feet and traveled 56 meters or 184 feet from its launching spot. Later, with support from aviator Charles Lindbergh and financial assistance from Daniel Guggenheim Fund for the promotion of aeronautics, Goddard moved to Roswell, New Mexico, where from 1930 to 1941 he built engines and launched rockets of increasing complexity. Meanwhile, in Europe, Germany was the most active when it came to space exploration. In 1932, Werner von Braun, at the age of 20, became chief engineer of a rocket development team for the German army. And after Adolf Hitler came to power in 1933, Braun was named the civilian head of that team under the military command of Walter Robert Dornberger. Yes, Germany under Adolf Hitler was using rocket technology to build missiles. The German government built a development and test center on the coast of the Baltic Sea to enable the engineers to do their work in secrecy. And here, the German engineers built the V2 ballistic missile in 1942, which was used on targets in Europe beginning September 1944. Even though it was built for purely military purposes, the V2 missile later served as the predecessor to many of the rocket programs of the United States and the Soviet Union. Interestingly, as the World War II neared its end, many of the German engineers in this program surrendered to the United States with the hope that they would continue to conduct research into their space exploration plans. And true to their expectation, they were taken to the United States along with their engineering plans and parts to construct a number of the V2s. While the German engineers were building rockets for the military, in 1936, several young American engineers, led by a graduate student, Frank Milena, began working on rocketry at the Guggenheim Aeronautical Laboratory of the California Institute of Technology, or Caltech. The group was supported by Theodore von Karman, who was the director of the Caltech laboratory, and it included Chinese engineer Xian Hyun-sen, who in the 1950s returned home to become one of the pioneers of rocketry in China. In 1943, Malina and his associates began calling their group the Jet Propulsion Laboratory, or JPL. During World War II, JPL became the center for missile research and development for the US Army, but after World War II in 1958, it became part of the newly established NASA, or National Aeronautics and Space Administration. Now, between 1946 and 1951, the US Army conducted test firings of the German V-2 rockets at White Sands, New Mexico. These rockets reached altitudes up to 200 kilometers or 125 miles before falling back to Earth. By now, the interest in space had gotten beyond mere military purposes, more towards investigation of Earth and its surroundings itself. So in the early 1950s, scientists began planning a coordinated international investigation of Earth. And this was called the International Geophysical Year, or IGY, and it was slated to be held in 1957 to 58 under the auspices of the International Council of Scientific Unions. By this time, rocket technology had advanced enough that the launching of an artificial Earth satellite seemed feasible. And at the urging of the American scientists, IGY planners in 1954 called for scientifically instrumented satellites to be launched as part of the IGY activities. And subsequently, the governments of the Soviet Union and the United States announced plans to do so. By now, the US and the Soviet Union had become Cold War enemies. And the United States specifically was very interested in developing the Earth satellite technology because that had the possibility of gathering intelligence of happenings within the borders of the Soviet Union. The idea of equipping such satellites with cameras and flying them over Soviet territory became very attractive to US planners, and the US Air Force began working on a reconnaissance satellite project. And one primary reason that the US government had committed itself to the IGY satellite program was that it wanted to establish the principle that outer space was not subject to claims of territorial sovereignty, so any orbiting satellite could pass freely over any point on Earth, which meant if the United States took pictures deep inside Soviet territory from an orbiting satellite in outer space, it would not be violating the territorial integrity of the Soviet Union. So while the rest of the world was busy figuring out a way to launch a satellite into space, on October 4, 1957, the Soviets surprised the entire world when they launched the first artificial satellite, Sputnik 1, into space. The Soviets had been busy building an intercontinental ballistic missile, or an ICBM, with an engine that was capable of delivering a heavy nuclear warhead to American targets. The ICBM was called R-7 and was successfully tested on August 21st, 1957. And this cleared the way for its use to launch a satellite. And as soon as this was clear, the Soviets quickly assembled a simple 83.6 kg or a 184.3 pound sphere carrying only 2 radio transmitters and 4 antennas, and called it Sputnik 1 and launched it into space. Their aim was to be the first to launch a satellite in space. A second larger satellite carrying scientific instruments and the dog Laika, the first living creature in orbit, was launched on November the 3rd. And an even larger instrumented spacecraft, originally intended to be the first Soviet satellite, finally went into orbit in May of 1958 as Sputnik 3. In May of 1955, President Dwight Eisenhower committed the United States to an IGY satellite, and the Navy backed the assignment. The Navy project was called Vanguard, but after it made little progress over the course of 2 years, the White House pressed for the project to speed up since Sputnik had already launched. But the mission continued to fall short, and the authorities then moved back to the Jet Propulsion Laboratory, or the JPL, and asked them to prepare a satellite quickly. On January 31st, 1958, the Jupiter C launch vehicle, a modified Redstone ballistic missile, carried into orbit Explorer 1, the first US satellite. The satellite was designed at JPL, and it carried an experiment to measure cosmic rays around the Earth. The initial satellite launches were scientific in character, but the US government was interested in the reconnaissance satellites because of the military edge it gave to the US over the Soviet Union. So in February of 1958, President Eisenhower authorized the development of such a spacecraft under a top-secret program. The project was called Corona, and its target was to take pictures over the Soviet Union and return them to Earth by dropping the exposed film in a capsule that would be snatched out of the air as it parachuted back from space. After several failures, the first successful Corona mission took place on August 18, 1960, and the returned film contained images of many previously unknown Soviet airfields and missile sites. Meanwhile, after the success of the Sputniks, the Soviets began working on the design of an orbital spacecraft that would be used for two purposes. One was to conduct photo reconnaissance missions and then return the exposed film to Earth. Yes, exactly on the same line as the Americans. And the second purpose was to serve as a vehicle for the first human spaceflight missions in which a human being would replace the reconnaissance camera. And the spacecraft designed for this purpose was called Vostok. The Vostok had two sections, a spherical capsule in which the person would ride, and a conical module that contained the instruments needed for its flight. The spacecraft weighed about 4.73 metric tons, and the crew capsule was completely covered by a thermal coating to protect it during re-entry. The human in the spacecraft was supposed to be a mere passenger with no access to instrumentation, and at the time of re-entry, the human would be ejected from an altitude of about 7 kilometers or 4.3 miles via a parachute to dry land while the spacecraft landed nearby with its own parachutes. On April 12, 1961, a modified R-7 rocket lifted into space Vostok 1 from the Soviet launch site, the Baikonur Cosmodrome in Kazakhstan. The spacecraft had a passenger on board, 27-year-old Russian test pilot Yuri Gagarin, the first man in space. The Soviets had stolen another march over the United States in the space race. And in June 1963, aboard the Vostok 6 was the first woman in space, Valentina Tereshkova. With the success of the Sputnik launches, the United States government sprung into action and debated how best to organize itself for space activities. At the time, both the US Army and Air Force were trying to play a central role in space exploration. In February of 1958, President Eisenhower created within the Department of Defense the Advanced Research Project Agency, or ARPA, which later became the Defense Advanced Research Projects Agency, or DARPA. And DARPA was assigned the responsibility for all US space projects. But soon afterward, President Eisenhower decided to separate civilian from the military space efforts. And that led to the creation of the National Aeronautics and Space Administration, or NASA, to manage the civilian segment. NASA began its operations in October of 1958 after approval from Congress. And by 1960, the JPL also merged into NASA. And NASA had its finest moment on July the 20th, 1969, when it stole a huge march over the Soviet Union as its Apollo 11 crew members, Neil Armstrong and Edwin Aldrin, became the first humans to land on the surface of the moon. A total of 12 Americans on 6 separate Apollo missions set foot on the moon between July 1969 and December 1972. Since then, no humans have left the Earth's orbit, but more than 500 men and women have spent as many as 438 consecutive days in space. And to top it all, the International Space Station has served as a base for humans living and working in space on a permanent basis. So initially, the investments in space research were very much focused on the military benefits of space research. In addition to providing security benefits, satellites offered military forces the potential for improved communications, weather observation, navigation, timing, and position location. And this led to significant government funding for military space programs in the US and the Soviet Union. But very soon, governments realized that the ability to observe Earth from space had other significant benefits to the general public. And the first application was the development of satellites for assisting in weather forecasting. Another application involved remote observation of land and sea surfaces to gather imagery and other data in crop forecasting, resource management, environmental monitoring, and other applications. On the military front, following the success of its photo reconnaissance satellites, the United States built increasingly complex observation and electronic intercept intelligence satellites. The Soviet Union also quickly developed an array of intelligence satellites, and later, a few other countries instituted their own satellite observation programs. And these satellites have been used to verify arms control agreements, provide warnings of military threats, and identify targets during military operations. A space application that began under government sponsorship but has quickly moved into private sector is the relay of voice, video, and data via orbiting satellites. In other words, internet in space. Satellite telecommunications has developed into a multi-billion-dollar business and has become a very successful business segment in the commercial space activity. However, an emerging and very exciting commercial application of space is the transport of fare-paying passengers, known as space tourism. This can entail carrying fare-paying passengers to the edge of space, generally set at about 100 kilometers or 62 miles altitude, and this would be for a brief suborbital flight that offer a few minutes of weightlessness and a broad view of the Earth. All this appears exciting, but it's not still at the stage that it would be commercially viable on a larger scale. Besides this, there are several other activities and technologies being looked at. For example, transmission of solar energy onto the Earth, or the transport of helium-3 from the moon to the Earth for use in nuclear fusion reactors. With all its potential, space still seems to be the final frontier of human exploration. And it is on that note that we end this section of the program. On to the quiz section. Question from the previous episode. What was the first dissenting vote or veto cast by China in the United Nations Security Council? Bangladesh failed to become a member of the United Nations in 1972 and 73 because China used its veto on behalf of Pakistan to prevent a full membership being granted to Bangladesh. So the answer is A, admission of Bangladesh as a new UN member in 1972. Question for the current episode. What was the first soft landing on another planet conducted by humans? Was it A, the Mars 3 landing on Mars by Soviet Union, B, Pioneer 11 landing on Saturn by the US, C, Voyager 2 landing on Neptune by the US, or D, the Venera 7 landing on Venus by the Soviet Union? Once again, what was the first soft landing on another planet conducted by humans? A, Mars 3 landing on Mars by the Soviet Union, B, Pioneer 11 landing on Saturn by the US, C, Voyager 2 on Neptune by the US, or D, Venera 7 landing on Venus by the Soviet Union? The answer will be provided in the next episode. That's all we have in the current episode. In the next episode, we go east and take a deeper look at China and its territorial claims in its neighborhood from Taiwan to the South China Sea. Till then, stay safe and keep looking for the why in history.